Okay, so Tibetan monk leaves the monastery at 7 a.m., takes his usual path and arrives at the top of the mountain at 7 p.m. So on the following morning, he does the reverse and arrives where he started. So we have to use the intermediate value theorem to show that there's a point, no matter how he walks up. So they didn't say actually, he walked in the exact same speed as he walked up, and when he walked down. In fact, when he walks down, right, he probably walked a little bit faster at certain points compared to when he walked up. So let me try to graph that for you. So this is time. X-axis is the time. And let's let the y-coordinate represents the vertical height. Okay, because the mountain we're going up, right? We're assuming the height of the mountain, so how high he is, the Tibetan monk, will increase over time. Okay, so let's say that's the height of his destination, and this is the mapping. Okay, this is the graph, the function which represents how he climbed up. So let me call that function f at x. Okay, remember, this is position, it's a vertical position. Actually, we can just say height. We can just say height. Now, in the following morning, so by the way, this took 12 hours. He walks down. Now, there's no guarantee that he walks down exactly the way he walked up, but it's not going to matter. Okay, so let me just draw a totally different one, something like this. Maybe he sort of he took the same path, but let's say he sort of took his time, and at the end he ran. He ran a little bit faster so that he arrives at the same destination in exactly 12 hours. Okay, and let me call this one g at x. Okay, and let me let f at x minus g at x, h at x. Now, you can see visually, this is their meeting. This is the position that's shared when he's going up and down. It's where the two positions meet. And note that no matter how the monk walks down, right? So maybe he did exactly the same path, but he could have walked a little bit faster in the beginning, walked a little bit slower later. Maybe he walked a little bit faster at the beginning. Do you see that it will still have to cross at some point? At some point, it will have to cross a particular position, right? As he exact same position as he was walking up. Okay? So imagine trying to draw a line, right? Trying to draw a line from here to this corner, without crossing this black line, right? If I ask the question that way, I'm sure you'll say, well, that's impossible. You have to cross it. So how do you put that? How do you say that using the intermediate value theorem? Okay, so let me plug in the beginning interval. So when time is 0. When time is 0, looking at the graph, you can see because they're in the two complete different positions, right? f at 0 minus g at 0 is clearly, this is a lot bigger. So we have a small number subtract by a bigger number. This is clearly negative. Okay. H at 12, so f at 12 minus g at 12, right? So f at 12 is referring to this height. Subtract by 0 height. You can see that that's clearly positive. Okay, and both functions of height, okay, height to the destination and height, the decreasing height as it comes down, they have to be continuous. If it's not continuous, that means somehow the monk wasn't at a particular height at a particular time, which is impossible, right? So this says basically a certain value c, so there exists a c in the interval 0 to 12, such that HSC has to be 0 because the sign is opposite. Okay, so therefore, right, Therefore, by intermediate value theorem, you can see there exists a C in the interval 0 to 12 hours, such that when you plug C into the H, you get 0. Okay, and that C is referring to this C value here. Okay, it's where the two positions meet, and it has to happen.